Hello all, welcome to my IoT Final presentation on the topic of a temperature excursion tracker. This is the motivation, design, and implementation of my project. The project topic again is the temperature excursion tracker. The idea here is that it's something that will collect time-stamped temperature data and export the results to a data analysis software. In this case, for this project, I chose Microsoft Excel to be the receiving data analysis software of the sensor data. This allows for analysis of when and how long something near a sensor may have exceeded an allowable temperature limit. My motivation for doing something like this is that the idea of medication storage came to mind, and I thought that was important maybe for some people who want to know, can I store my medication in my bedroom, bathroom, or kitchen, or none of the above? How hot does my kitchen get when I cook? Does the bathroom cabinet get too hot in the summer? Or are there spots in my refrigerator that get too warm that might not be cold enough to preserve insulin or other refrigerated medicine? Other things besides medication storage, how hot does my car get overnight? Will my equipment get damaged if I leave it in there? Things like that, and it depends on a person's profession or lifestyle, but a lot of different reasons for wanting to know the temperature of an environment can come up. These are just theoretical examples, but I wanted to at least get a proof of concept down, and in the future, maybe to improve on this design, getting cordless sensors would be even more effective at isolating certain sections or small areas of temperature sensing. But anyway, this was the main motivation for the proof of concept of something like this. And furthermore, my additional motivation is to gain more familiarity with Arduino. I really had a desire to kind of explore the growing community, and there's new and powerful Arduinos becoming available frequently, and I wanted to gain familiarity with the new tools. So this is a fairly simple project, but I cover some powerful topics, and I had these 5 main teaching points I really wanted to hit for myself. First, just sense the environment through some of the ports and onboard sensors, then convert the sense data into readable and transferable data, then send the data wirelessly, and then demonstrate the ability to process the received data from the network on the data analysis software, and then finally trigger some of the auxiliary components based on the actual data that was sensed on the Arduino. And pretty much overall this covers the main motivations and reasons for doing this project. So with the motivation and project topic covered, we'll get into the design. The design here, these are just the main components when they're not connected. Got the breadboard, the connectors, thermistors, and then some new parts for the final part are the LED over here and resistor. And this is what the Arduino board looks like when it's not connected to anything. This is what it looked like when first setting up the temperature sensor. You could take a closer look at which goes where as far as like the 5-volt connections, the A0 pin, and then this is just another angle to see exactly how it's set up. And then this is really finally what it looks like after using this male-to-male USB cable to load the Arduino software onto the board. This AC power adapter gets plugged in, and that's how it will transmit through this wireless sensor to the computer. And these are what the connections look like. These are the 2 resistors. You got the thermistor over here, and then the LED light over there. So that's pretty much the basic gist of what it looks like from the hardware perspective on the implementation side. So that brings us to the software. The software here is the Arduino IDE for Windows 10, and that's how I interacted with the Arduino hardware and the laptop using that USB I showed on the previous slide. And the Python 3.7 for Windows 10 was how I made the server to interact wirelessly once the board had the software on it. And finally, Excel 2003 is the final destination for the software. So to quickly run through, this is the main part of the design of the Arduino software and what the Arduino IDE code looked like. It initialized the serial USB connection and the IMU module device, and then waited for a serial connection and attempts to connect to Wi-Fi, and then it loops through and does nothing if there's no Wi-Fi connection, and you can reset it to get it to work again. And a lot of this was just standard stuff shown by the Arduino Wi-Fi Nina library, which kind of just helped me get the initial setup going. And building off of the setup here, the next step was to go into the core loop for the Arduino software. The core loop, after the Wi-Fi is set up, does three main things. First, it maintains a waiting for UDP message state and sends a reply upon receipt of the UDP to the board's IP address. So you'll see later the Python software is set up to send a timestamp. So that's how the board will get the timestamp, and it'll attach that sensor data in the second step to the timestamp that it received from the sending server, and then it'll reply with that combination string of the timestamp and temperature. And then the third thing that it will do is turn on the LED if the temperature is too high, which in the Arduino code here I set to 80 as a general cutoff there for that. Now the software for the Python server, this is the setup. It just includes all the different modules needed for imports and setup, and it also accepts user inputs for the number of data points desired, the time interval, and the temperature alert threshold. That's what's going to get exported in the Excel spreadsheet, not necessarily turn on the LED. The additional parts of the software here are the different loops. First off, the initial loop establishes a UDP connection per loop and uses exception handling just to see if any point of the send and receive goes wrong. And then it appends each data point to a list as it receives from the Arduino after a successful send and reply occur. And then the follow-up loop at the bottom is there for having an easy enough data structure to export to Excel. With that done, then this is the export code that I used for the Python to export to Excel. And this also has some exception handling, so if one of the files is successfully written and then left open by mistake or not accessible, it can make an alternate file and save there. But that's the limit of the handling I have for that. But here's just basically how the data is written to the sheets, and as long as the data is formatted well, it's fairly straightforward. Finally, the sample output here is what it's going to look like. The idea is it's got the timestamp, onboard, and aux sensors all put together, and it will print the word high in the fourth column if anything is above the limit entered by the user. So this can help maybe aid in the data analysis a bit, but overall you'll see this more in action in the demo that I'm about to show coming up. Okay, now it's time for a demo of the Arduino program and the Python program on the Windows laptop in action. This is what the Arduino and breadboard look like when they're set up here. This power cord is connected down here to a power strip, and as you can see, that goes right here into the Arduino. I'll try to zoom in here a little bit on the connections there for some of the wires coming out, and just to get a little bit of a view on this side. Pin 13 is where the white wire is going into. You can see that connection along the positive end of the breadboard goes into the resistor here, which goes into the LED and then gets grounded back with the green wire. And then up here, these are the connections for the thermistor and the resistors. So that is what the hardware is going to be sending wirelessly to the laptop over here. And the laptop here in a folder with what's going to look like having a sensor export is going to be the output at the end of it. But I'm going to go ahead and delete that right now. And what you'll see is when I run this program, which is going to be this code over here, I'll run that. It'll come up just like a command line program. And you can see over here that it's going to attempt to retrieve the values from the Arduino, and it wants to know how many values to attempt to retrieve. So we'll just go ahead and do 100, give us some time to talk through it as it's going, and we'll receive 1 second delays
and finally I'll have it alert the temperature as high if it's above 80 degrees. So starting that now, you can see on the far right the temperatures are coming up from the auxiliary sensor. As you can see here, the LED light is not on. I'm going to go ahead and grab the thermistor here, and that should hopefully start elevating the temperature values. And as you can see, I got it to about 75. There we go. Now it's hitting almost 80. I'll just warm my hands up a second here, and there we go. We got some values coming up there. And now as the 80s come up, you'll see the LED light goes on and off if it goes below 80. It's a little hard to control. There is fortunately something in my favor that's a bit of a glitch that's working, is that there seem to be voltage spikes, and the temperature unfortunately is not very sensitive. So occasionally I am getting issues in the actual temperature reading. Unfortunately, I didn't have a voltimeter to go ahead and troubleshoot that, and multiple sensors were seeming to have those issues. So in any case though, when I'm not touching it, you can see the light is out and it's low, so it does show the temperature readings effectively. So at least the proof of concept is there. We just need to see if it could have been troubleshooted a little bit better on a hardware perspective, but alas, I didn't really have the equipment to do that. In any case, once this is done, you're going to see the file printout right here in the folder. After all the readings are done, it's going to show the sensor export. So let's just see how many more we have. Also, this black screen is set to print all the values and then time out after 5 seconds, which is when you'll see the appearance of the file saved right there. So this should be how it's going to end up looking. Okay. As you can see, the file name is sensorexport.xls, and we've got the timestamp over here. And these are the temperature readings in string format. As you can see, it has the same readings that I was getting printed, and it prints high next to anything that was higher than 80. And it looks like it did successfully print out all 100 values. And at the end, when I wasn't grabbing the sensor, clearly the temperature dropped back down. So I can also do a really quick demonstration on what it will look like if this file is still open and I rerun the program. So I reran the program, and we'll just do a quick 5, 1, and it doesn't matter what temperature I put in. Could put in 90, it won't do any high values. So it's going to receive for 5 seconds, delay for 5 after it prints out the data list, and then over here it should put up the alternate sensor export, and as you can see there, it did. So let's check out what that looks like. And as you can see, it exported it to the alternate name XLS, and it looks like we have the timestamp values again and the data readings. So that shows the variability and the extent to which the program will handle requests like that, and that it will export to the file in the folder there. You'll have the data analysis XL format files. Thank you very much, and that concludes this demonstration.
With the demo concluded, I'd like to sum up with some final reflections. The project results demonstrate the concept effectively, but I was not able to fully fix or calibrate the hardware. It ended up being probably about 90% accurate, but there were some clear precision issues with there were many multi-degree jumps. I may have needed better sensors calibrated to the specific Arduino or breadboard. I had tried, because I'd seen a lot about the Steinhardt-Hart equation, to use that and to manipulate the readings and adjust for the voltages. But without additional voltage testing equipment to see the source as the Arduino or the thermistors themselves, the effort was fairly fruitless and futile, so I unfortunately was not able to progress further with that aspect. Finally, some quick aspirational progress. Anybody who else tries this might want to try doing a sensor with extreme temperatures, so I thought it'd be interesting with any advanced cords or even a small battery cordless Bluetooth type transmission that could send the signal to a receiver and then put it into the Arduino pin readers to keep the Arduino separate from the extreme temperatures. So those are some interesting thoughts I had to conclude with. But in any case, I appreciate it very much. Thank you for your time. That concludes this demo.